We are going to start with Emmanuel Bacry, who is a scientist based in France. He has had responsibility, for instance, in collection and management of data, health data, which is very important. I mean, they were always very important, but their importance has been understood better during the COVID crisis. And so, as I explained yesterday, I thought that everybody discusses artificial intelligence, but not always with much intelligence of artificial intelligence. And so we will start with the presentation of Emmanuel. And at the end of his presentation, I will be happy to answer questions if there are still question marks in your mind. So Emmanuel, over to you.
Thank you very much, Jean-Marie. Thank you for inviting me. I'm very glad to be with you. Well, I wish I were with you in person, but I could not make it, so I'm really sorry. But I'm very excited by this afternoon for me, morning for you. Okay, so I'm in charge of talking about artificial intelligence and trying to make you understand what it is and what are the challenges, the bottlenecks, and main applications and so on. So it's a pretty heavy task. It's not that easy, but I'll do my best. And I thought it was a good start to start with a definition, even though there are plenty of definitions, and I guess that it's a very subjective uh, um, it's always subjective definition of artificial intelligence. So I will give you mine. I mean, it's not mine, it is shared by a lot of people, but one that I feel close to. And my definition will stress the first word of artificial intelligence. You really have to understand this is artificial. And what do we mean by that? It means that it's a set of theories and techniques implemented to create machines capable of simulating intelligence. It's about simulation of intelligence. We are not trying to reach intelligence. I mean, at least that was the initial goal of artificial intelligence. That is very clear, and it is very clear if you know or if you've heard about the Turing test. So that was made by Turing a long time ago. And the Turing test was about trying whether you would be able to guess chatting with a bot through your keyboard, if you would guess if it was a bot or if it is a human being. Okay, so, and Turing said, basically, he didn't put it into these words, but basically it said like, if we can deceive you, then it means that we succeeded in the artificial intelligence program. Okay, so you see that it's about illusion. It's not about being really intelligent. It's about giving you the illusion that it is intelligent. And I think this is extremely important. And today, when we are talking about ChatGPT and other big language models, we are really reaching this goal, which is a simulation or an illusion of intelligence. But I'll come back to that. Now, just for the fun of it, and it's a less serious definition, but I like also this definition. AI is the ability to solve complex tasks without being intelligent. Okay, that I think sets the framework pretty clearly. So let me do a little history of artificial intelligence. Basically, historically there were two main approaches. The first one, which is generally referred to as symbolic AI, it's a rule-based system, so it's like what we call also expert system. So basically, it's something which looks like if you have a temperature, if you are coughing a lot, and so on, then we can conclude that and that and that, and the experts would list would put in the machine a list of rules, very complex rules, so that the machine can take decision, can say, act as a doctor and so on. So this is what is called symbolic AI. And it reached its peak in 1997 with the success of Deep Blue. I guess you've heard about Deep Blue, which was the chess champion. I mean, the computer, the IBM computer that beat the champion of chess at that time. And that was symbolic AI, meaning that the computer had tons of real plays, chess plays that real human beings played, tons of overtures for playing chess and so on, tons of rules, expert rules, and so on. Then you had the second approach that was parallel to the first one historically, which is called statistical AI. And basically, it is based on data a lot. So you need a lot of data. And today, when we are speaking about AI, basically, we're speaking about statistical AI, though I think we should, and we will go back a little bit to symbolic AI in the near future, but we will discuss that later. But today, mainly when you hear talking about AI, we are about statistical AI, so AI based on data, and I will explain more about that later. So it started in 1957. There was what we call the AI winter, where not much happened. I mean, there were some inventions, but not much. And then 2012, that was a big change. I'll come back to that. A big move and with some very big improvements. And then maybe one of its peak is AlphaGo. So that is in mirror to Deep Blue in 2015, which was the software, the model from DeepMind that beat the champion of Go player. Okay. And then, of course, we have to talk about ChatGPT and so on, which is another peak. So why 2012? What happened in 2012? Well, that's what happened in 2012, basically. Basically, you had Facebook that was overwhelmed with, overfilled with pictures of cats that people posted and with the caption saying, "This is my cat," or whatever. I mean, the caption being clear that there is a cat on the image. So it means that Facebook had access to tons of cat images and knowing that it's cat. Okay, so they use that to develop a big model to try to guess whether on the image there is a cat or there is not a cat. Okay, so cat recognition. That was a major improvement because then they built this big image model that was used afterwards for a lot of image applications that are not at all related to cat. So here's just for fun again, human versus AI match, and I'm saying it's an uneven match. So basically, the AI to be able to run, you need a cloud center. If you look, I'm comparing the AI with a 3-year-old child, okay? And the brain of the 3-year-old child is about 0.1 meter cube. So very, very small compared to the cloud center. The accuracy of the AI is about 98%. The 3-year-old child will always recognize a cat, so it's 100%. The number of examples the AI needs to be shown so that it can do the work is about 100,000, whereas a 3-year-old child just needs to see 3 cats to be able to recognize a new one. The power consumption, I mean, clearly the brain versus the cloud center, there is no comparison. And the multitasking also, I mean, the 3-year-old child can do a lot. The AI that is trained for recognizing cats, that's the only task. Okay. I'm a little bit unfair when I do this because I'm putting under the carpet something, which is that the 3-year-old child has has been living for 3 years and had seen a lot of stuff about life. Okay, other things, not cats, but he learned a lot about objects, about animals, about stuff like that. And I cannot just compare it. It's a little bit unfair to compare it to an AI that was just trained to recognize cats. But this comparison is mainly to point out the fact that we are not with AI, and at least with the initial project of AI, and it's still true today, we are not trying to simulate the way human intelligence is working. Not at all. We are trying to give an illusion of the final result of what human intelligence is able to do, but the systems themselves, maybe at the beginning, the first people who invented the deep neural networks and so on, they tried to mimic the brain. But today we are very, very far from that. And everybody agrees that all the big models you've heard about have nothing to do in the way they are reasoning, in the way they are concluding, or they give some conclusion and so on, are using the same path. They are not using the same path at all and the same process as a human brain. It's totally different, totally different. So this is just as an introduction. And now I would like to move to another part, which is a part where I'm going to give you the main types of AI. There are several types of AI, and I would like to discuss with you the main types of AI that you might meet in your everyday life. Okay? And the first one, which is clearly the most deployed, I don't know the numbers, but I would say that maybe 90% of the AI that is developed is supervised AI. Okay. So supervised AI is what? It's exactly what I just told you about. It's the cat recognition problem, meaning that we ask, it's supervised by a human, meaning that a human has to annotate the data saying, this is a cat, this is not a cat, or takes an X-ray and here there is a cancer, here there is not a cancer, here there is a cancer, here is there's not a cancer. And what we expect the AI to do is to reproduce, to be able to reproduce the conclusion of the expert, showing a new image. Is there a cancer or is there not a cancer? Okay. So this kind of task, again, is the most common AI today. And it is called supervised AI because there is, before deploying the AI, to train the model, it is supervised, the process is supervised by an expert that will say what to say on this X-ray, what to say, is there a cancer or not. Okay, so supervised by a human. So as I said, you see it. I mean, this is almost everywhere, not everywhere, but in a lot of applications or that you are using in your everyday life. And of course, it has a lot of applications in health, major applications in health. It is pretty new. It started in 2018, the first time that the FDA approved a first AI-based medical device. But now there are hundreds of them that has been approved in the US. Europe is slower, but in the US, this is very clear. There is a big boom, and now there are a lot of supervised AI that are on the market. A lot of them are about images and trying to give some diagnostic help to the doctor reading images. Now you have supervised AI also in some other applications, so recommendations. Okay, so recommendations is a little bit different way of supervision. It's not a strictly forward supervised AI. Basically, you like this book, and this book, you should read this book. Okay, this is recommendation. How does it work? Well, the AI learn not from an expert, but learn from example. All the other, well, 90% of the people who liked the book A, B, and C liked D. So if you liked A, B, C, I'm going to push you D. Okay, so it learned not from an expert, but from a supervision that comes from the client database or whatever, if it's for movie or if it's for news, like as in Google News. You have supervised AI also in advertising on the net. Whenever you are surfing on the net and there is an ad on your page, on the web page you are on, uh, the ad, the way, the process to decide which ad to print, to display to you is a process that takes about 100 milliseconds, and that a lot of actors are involved. And there are many places along the process that involve supervised AI, and it's mainly about trying to profile you. So trying to understand what you like, what you don't like, what gender you are, and so on, to target, to have the best targeted ad to send you. Okay, at the very end, you know, the ad system is is on the market, like a financial market, okay? And people are betting in order to get the opportunity to print an ad. And of course, if I'm I don't know, if I'm selling some fish accessories or whatever, and if you were profiled as being interested in fishes, then of course I'm ready to pay much more to get the opportunity to send you and to print on your web page an ad. Okay, so there is some supervised AI here because I know that I don't know, like each time I printed this ad to some 30 years old man who was interested into fishing. Well, it worked. The person clicked on the on the on the ad. Okay, so now I'm doing a supervised AI algorithm that will try to guess whether if we print this ad, you will click on it or not. Okay, so we have many examples again. It's always supervised. Many examples are given to the AI and try to reproduce what we know about the data or about the human being when it's about profiling. So all these examples, I'm sure you are pretty aware. I mean, most of you are pretty aware that it uses AI. Now there are some applications where it's not that obvious and people do not know. But when we're talking about that, it's full of AI, this also. It's full of profiling. Behind such an application, so I guess you all recognize a game, the very popular game that you can play on your phone, right? And it's the same thing for all the games you play on your phone. Basically, you have about 100 data scientists, so these are AI experts working behind the scene on this game. And you have six addictolog doctors trying to keep you. The whole goal is to try to keep you on the game as long as possible. Okay? And it's done in a supervised way because they are going to record all what you do with your telephone as much as possible, following the regulation. Okay, and then they have huge databases of people that use the telephone as you are doing. Okay, it's like for recommendation. And they know that when to these kind of people we send a little red form with this exact shape, and so on, then you have a tendency to stay in the game. Okay, so this is supervised AI that will decide at what time which shape of which color will be sent to you to maximize the time you will spend on the game. Okay, so and this is true of most of the games that you can play on the phone, right? There is always a supervised AI behind the scene to try to keep you on the game. There are huge impact on public health. Okay, it's a major problem of public health, this thing with addictions and stuff like that. Of course, it's free. So all the regulations you can have on games where you have to pay. You know, in Europe we have a very heavy, and in France we have heavy legislations about that, heavy regulations about playing poker online or betting for sports online and so on. But this is not all this regulation. The scope of this regulation is not this game because this game you can play it for free, but you know it's called pay to win, so you have to pay if you want to win. And of course, these are the people that are targeted. And you can spend. I mean, I know that like the the highest individual account, and the people who are spending the most money on these kind of games can spend like $300,000 a year or something like that. It's enormous. Okay, even though you pay by $4 or $5 each pack, some people are totally addicted. So it's a very important problem for public health. Okay, so that was supervised learning. Now, at the extreme over end of supervised learning, you have, of course, unsupervised learning. So unsupervised learning, as it says, it means that it's an algorithm that will try to extract some information from the data without being given any example. Okay? So let me give you a very theoretical but very simple example. Imagine you have data about some people, okay? You have database of people, and what you know about these people are three numbers: the weight, the height of the person, and the age. We all know that when the age is a small number, so when the column age is small, the weight and the height are very correlated. Okay, these are the curves, very, very classical curves for children, right? And this is very easy to see and to check. Okay, now imagine that each person you have in your database have not only three numbers, but have billion of numbers to characterize them. I have all the DNA of the person. I have all the X-rays. I have all the healthcare pathways of the person and so on and so on. Okay? And I don't know. I mean, in the middle of that, there is a column that is age, another one that is weight and height, and I don't know about this column. It is going to be really hard to understand that when the column number 1 million, whatever, has a small number, then I have two random columns in this huge array that are extremely correlated. Okay, this is an information, this is a structure of the data that is extremely hard to guess unless you try all the triple of all the combinations of three different columns and you try this game. But there are too many combinations if you have billions of columns. So it's impossible. So an unsupervised learning algorithm would be able to just take this huge table and say, oh, I, I noticed a structure that when this column here has small values, then these two columns are heavily correlated. Okay? So this is unsupervised learning. No example. So, of course, it is way more difficult than supervised learning, and we are not very advanced in unsupervised learning. There are few things we know how to do, but not a lot. There is huge research on that because it's promising, but very, very hard. Let me give you some simple examples, and it's about clustering. Here is a clustering of tweets accounts during the first US election of Trump, okay, trying to group people that look alike, that have the same kind of activity. And in that way, you see that so it's a paper in 2020 that was published by researchers. I'm sorry, I should have mentioned the reference, but it's an academic paper. And basically, they have identified a group of people that is a follow back cluster of pro-Trump. So meaning that they are following the main pro-Trump cluster and they are listening to each other and they have a heavy traffic internally to the group, intern to the group. Okay, so here it's we asked the unsupervised learning algorithm to find some groups that make sense and to group people that look alike or tweet accounts that look alike in their activity. Okay, and that's the representation. I have the same thing. I don't know if you see it, if it's clear enough. I have the same thing about the election in France, but it's a better, I like very much this analysis where you see how the algorithm has dispatched everybody. So I'm sorry, you might not know very well the political ecosystem in France, but clearly, so that was the election of Macron. And you see that we have all the left wings people here, and then Macron, which is kind of right at the center, okay, on the right at the center. Then you have extreme right here, and then you have some independentists here that are totally alone, and so on. So you find a structure that is very informative. Well, for us, it's not that informative because we already know the structure, but you can see that the algorithm has found some structure that we already know. Now imagine applying it to some heavy data that you do not know the structure of. Well, it could be enormous. Let's say I have I have data and all the healthcare pathways of all the people that that have a diabetes of type 2. Okay, that's an enormous in France, where I think there are more than 3 million people. If I were able to do some clustering on this data and do clusters in the same way I do the clusters of tweets, I should be able to tag group of people and pathways, healthcare pathways for diabetes that are very efficient, both in terms of health and in terms of economy and the terms of how much it costs. Okay. And it would have major impacts. Okay. And luckily, this is hard for healthcare pathways. Nobody is able to do that. The structure of the data is too complex. We know how to do it on tweets accounts, but to do it on healthcare pathways, a lot of people are working on that, but it's still, I mean, we're still not able to do and to solve the question I just mentioned. So this is unsupervised learning. Then in the middle, we have reinforcement learning. So it's a mixture of the two. Generally, reinforcement learning is about a goal that you want to reach, and you don't know what is the path to reach the goal. So what is the process to reach the goal? And you have to take decision at every step of the process. And you don't know what is the best decision at each step in order to reach the goal. So here we have an AI algorithm that is trained by just uh, letting it try the process, any process randomly, and we just so it's a trial and error process, and it receives a reward or a penalty if it has made a good or bad decision. But just looking at the end, we know at the end whether the whole thing was good or not, and we just say it. I mean, we just put that in the computer. Okay. The main application is AlphaGo. AlphaGo was working like that. The second version, actually, of AlphaGo, the one which is really the best version, which is amazing in terms of performance, is truly working like that. So basically, it's an AI system that just at the beginning of the training, it just knows the rule of the game, and that's it. No libraries, nothing, no real games that were played, and so on. And it just plays against itself. Okay. And of course, the rules of the game are very simple. So at the end of the game, it knows which one won and gives to himself the reward or the penalty and learn like that. And that's how the AlphaGo was designed. And now it's like unbeatable. I mean, it's clearly the champion of all the Go players today and way, way ahead of all the human players. So this is reinforcement. It's very attractive because imagine applied to health, it means that you could correct it online. Like I'm a doctor using an AI system like that. If I see that the AI is wrong at some point, I could say, this is wrong. So you change now and you update your system so that you integrate the information that in that case you answered badly. So this is very, very appealing. Now, there is a downside, which is that for any sensitive application like health, you have to go through a certification process to deploy it on the market, to deploy your system on the market. So there is no way you can change the AI and say, oh, here you made an error, so update your training without going through another certification process. So you cannot do really that. So this is good for applications that are not as sensitive as health. And then the last type of AI is what I call self-supervised learning. I could have called it generative AI to make it more demagogic. Most of the not all, but most of the generative AI are using self-supervised learning. Okay, so basically ChatGPT is within this framework. So what is it about? It is a supervised learning AI, okay, as I described with the cat thing. But now the task is so simple to supervise. So the answer is so simple. I mean, to get the answer is so simple that the computer, the algorithm can supervise itself. Okay, so we don't need any expert. Okay, so the supervision is made 100% made by the machine itself. Okay. What the hell do we do that for? So initially, it was not for chatbot. initially, and it is still heavily used for that, we defined pretext tasks. So the goal was not to solve these tasks that were very easy to solve. Okay, we call them pretext tasks. And we define pretext tasks with the hope the algorithm, and I will explain what it means right after, will learn semantic representations of data and how to encode and decode to or from these learned representations. So some coding with numbers that have a close relationship with the meaning of the words or the sentences of the paragraphs. And then these representations will be used heavily, and it is done today, by supervised algorithm in order to develop some applications. Let's imagine I want to, I don't know, I want to recognize if on an image I have a cat or not a cat. I would need 100,000 images to do that from scratch. I'm going to use one of these big foundation self-supervised models for images that learn a representation of the image that is semantic, that has a structured information in it, hopefully. And I will use them, I will train my supervised AI algorithm by first encoding all my images within these semantic representations. And then I do the last mile, the last step. I just do the learning from this representation to is it a cat or not a cat? And this is I don't need a lot of images to do that because it is a very small model. The very big model that we mutualize for a lot of AI algorithms has been trained on tons of images or tons and tons of texts. Okay, so we learned representations that will be used all over the place for other AIs. That was the initial goal. Let me give you an example. So for GPT or ChatGPT, okay, what were the pretext tasks? So the pretext task were either I take a text, I remove a word, and I have to guess. I mean, the AI system has to guess which word I removed. Of course, it can play this game alone. Okay, it's very easy to remove a word from the text, and the text you can scrap all the text on the web. Or you can just cut the sentence or paragraph in two and say, what is the next word? And then the next word and so on. Okay, and then you can, of course, do generative AI this way. Let me give you one hint about what these representations are. This is a very basic version of these LLM models, okay, representation. It's called Word2Vec. You can find it on the web and play with it. So each word are coded using 200 numbers, okay, like coordinates. We are living in a 3D space. So if you give 3 coordinates, you have a single point in the space. Here we have 200 coordinates for a word. And we ask the AI, the self-supervised AI, to solve this pretext task, guessing the next word or guessing a mask word. But we force the system to pass through a representation of a word in terms of 200 numbers, which is very low. And we force in that way the system to try to find the most clever numbers so that it doesn't have to re-encode the meaning of the word each time. And it will learn, and you can check that if you look at the difference between king and queen, it's exactly the same difference between man and woman. So strictly speaking, I take the man word, I look at the representation that was learned, 200 numbers, I look at the woman word, 200 numbers. I subtract on each line, I subtract the two numbers. Okay, so I find a kind of distance, a vector of distance. Okay, and if I do that with king and queen, I find the exact same vectors, the exact same numbers. Okay, so basically you can ask Word2Vec online. You can say, okay, I take the word king, I subtract the word man, I add the word woman, what do I get? And it would say, you get the word queen. So you check by that way that the representation that was learned do contain some semantic information. Today, with the GPT and all stuff, we are not only encoding word, we are encoding sentences, paragraphs, documents, images with paragraphs, images with captions or whatever, sound or whatever you want. But it's always the same story. And we need these foundation self-supervised models to learn these representations that will be learned once for all and shared to everybody to develop some other applications like a translation of text, like whatever, speech to text, text to speech, or whatever. Okay, so we use, as I said, we use these representations and large models for fine-tuning. So for all the other AI applications, supervised applications, and it is a major use of the GPT stuff. Okay. Of course, and now you know about that, there is a huge application, which is the generative AI. Okay, you generate text, and of course, you know that, and the chatbot and so on. And there are some challenges now about these foundation models, which is that you want to build multimodal representation. You know that GPT-4 or Mistral or whatever, you can do text and images, but we want to do text, images, videos, audio, 3D, genomic, healthcare pathways, whatever. Okay, we want plenty of modalities and being able to do that. We are far from that yet. Having so many modalities, it's very, very complex. Okay, but this is one goal. Now, let me tell you a little bit about the chatbot itself. I told you a lot about GPT, which was 2018. That was this LLM model. And in 2022, if I remember well, OpenAI released ChatGPT. So what is the ChatGPT? Chat is a layer, a single layer on top of the old GPT model. What is this layer for? Well, it's the fact that if you use GPT as is to generate sentences and text, you'll make it's very easy that it will say it will become racist, xenophobic, violent, and so on. So you want to add some form of censorship layer on top of the LLM, on top of the models I was talking about, this big self-supervised model that learn representation. You need something on top of it. And that's exactly what OpenAI did. They paid some people to try to provoke GPT and make it racist, xenophobic, violent. And by reinforcement, exactly as AlphaGo, when GPT became racist, xenophobic, hop, penalty. And if it answered well, being very, very politically correct and so on, then they will give GPT a reward. Okay, so it's basically adding a reinforcement layer to this huge self-supervised model, foundation model. And this reinforcement here is made by human. So there is this famous article by Time Magazine you should read, where you see that it was done by a Silicon Valley startup that hired a lot of people from Kenya. They were underpaid. They worked 10 hours a day, and half of them had a nervous breakdown because you could imagine without a ChatGPT, without any censorship layer, you can have like huge text like that with like extremely violent descriptions and so on. And they kept reading that during the whole day. Okay, so there is this uh, uh, layer that was added. So it's censorship, and according to what rules, nobody knows. Okay, that's a major problem for regulation because nobody knows. Because when are doing censoring, you censor with some guidelines saying you should not be like that or you should answer like that and so on. Nobody knows, and OpenAI did not release the guidelines for this censoring. And same thing for Google, Gemini, and all this stuff. Okay, there was this story. I don't know if you heard about it. That was very interesting. There was a scandal when somebody asked Gemini to generate an image of two Nazi soldiers, and Gemini generated a black person and an Asian person. Okay, because clearly there was some censorship saying that all the minorities should be represented and they have to be careful about that and so on. So this layer is extremely important, and that's clearly a layer that can gives a strong orientation of the answer. I mean, you all know the late also example of Grok, so that's the LLM of Elon Musk that keeps talking about the genocide in the South of white people in South Africa. So this is all about this censorship layer. Okay, just to finish on this self-supervised AI, I just want to stress one very important thing. All these chatbots do not have any model of knowledge, logic, or grammar. I'm not cheating when I tell you that if you look at the whole training process, so the whole building process of these LLMs, they have never ever been trained to tell the truth or to tell something true. Why? Not because we are not interested in it, but because it's out of reach. We don't know how to do that. We know how to censor to be politically correct. We don't know at all how to make it sure that it's not going to invent some stuff and so on. Okay? So this is very, very important. We are really at it's like the ultimate goal of Turing. We have an illusion of intelligence, but clearly we are not reproducing human intelligence. Okay? And it is very important that you understand that when you are using these tools, that you have always in mind that when it states something false, it doesn't make any error. The model was not programmed not to say only truth. It's not an error of the model. Okay, it's just the fact that sometimes, okay, it's normal. It just guesses the next word. So sometimes it says something wrong, and there is nothing abnormal to that. It's the reverse which is abnormal. It's extremely surprising that it doesn't say more wrong things. Okay, but don't trust it. And I know it's hard. And for me, it's the thing we have really to fear. It's not the fact that we are going to deploy ChatGPT and that our kids are going to use ChatGPT and so on. The thing we have to fear the most for me is the fact that we all, after spending 10 minutes on ChatGPT, we all forget that it's not telling the truth. I mean, there is nothing that guarantees that what it says is good. The illusion is so good that we are kind of trapped. And that's, I think, the thing which is very dangerous. I do a lot of conferences to a lot of experts and to doctors. Doctors, when I tell them that these things they were not trained to tell the truth, they don't believe me. They think I'm just cheating and I'm not saying the truth. Okay, it's very, very important to keep that in mind. Okay, so I told you about four different types of AI, right? And now I would like to move to some other topics. And I know we have a panel about the data, but I want to talk about the data and how important the data is in the framework of AI. It's the heart.
Maybe, Emmanuel, I was wondering whether if there are any questions at this stage.
Sure, sure, pleasure.
Thank you and good morning. Thanks for this really insightful presentation, Oliver Grünbach, with the Austrian presentation at the end. I couldn't help but wonder, isn't already a large part of, I would say, the internet generated by these generative AIs? And so if these, let's say, ChatGPT keeps collecting data, isn't it collecting its own data and then kind of also I would say reinforcing this chat layer that has been put on top of it. So whatever was kind of defined as its truth or the degree of censorship, isn't this becoming the truth eventually? Because the majority of data on the internet maybe has gone through this layer.
Yes, I like to talk about the truth, but I totally agree with you. I would not put the word truth. You know, when we are talking about a supervised AI, we have what we call, it's a technical word, the ground truth. The ground truth is if the expert said there is a cancer or not. On this model, there is no ground truth. Okay, that is important. There is no truth. We don't care about the truth. But I totally agree with you. It's very hard to estimate what is the percentage today on the web of contents generated by these models. It's extremely hard. But clearly, this is a very big problem with these models that are very used and that are using what they produce to learn. And of course, there is a loop here that is extremely dangerous with all the biases you can imagine. And this censorship that is learned, and this is becoming the norm. Although, of course, the norm for the Chinese, for the European, and for the US are not exactly the same norms. But still, there are like norms like that. And again, another thing, another technical word that is, I think, very insightful and very interesting to know is the censorship procedure is called the alignment of the model. So it's really about aligning to a moral or to some morals and so on, except that we don't know what is the moral underlying.
Thank you very much. I'm İlke Tanlay from the Turkish mission. I'd just like to ask you two quick questions, if I may. First of all, at the beginning of your presentation, you gave examples about the symbolic AI. And then you also mentioned Deep Blue at the very end. You said you'd get back to it, but you didn't.
Yes, thank you.
So I just wanted to remind you of that.
Yes, thank you very much.
And my second quick question is on the reinforcement learning model. You mentioned the caveat of health programs being certified, and then, well, after they've gone into the market, you can't readjust them or recertify them. However, couldn't you overcome this issue through software patches, perhaps, like sort of re-instructing that already certified program?
So
Thank
let me answer the first question first. So thank you for reminding me of talking about that. Yes, clearly there is a tendency today of many scientists that say we need to associate these big models with some expert system and symbolic AI, where we are able to encode logic, grammar, and so on. And we have to try to make these kind of systems work together. So the ChatGPT would be an API, would be like the interface you would be dealing with, but underlying it, ChatGPT would, or any other LLM model, would be discussing with some classical symbolic AI agents that could not make any error of logic or whatever. So a lot of people are trying to mix the two. We have not reached at all yet this thing, but it's a direction that I think is a good direction. I think we reached the best we could do with these LLMs, and now I don't think I think it's a little useless to go in the same direction, and many scientists think that. Now, your second question was about reinforcement learning, and you are right. I was a little bit excessive. If you do a reinforcement learning algorithm and you certify it by FDA or in Europe by a European certification institution, strictly speaking, if you change a little bit the training, or if you update a little bit the training, you don't have to go through the whole process. You can just do like you would do for an update of the software. But it's still like in Europe, I don't think that exists because it's not that easy to address in terms for the regulator. It's not that easy to measure what is a big change, what is not a big change. How you have parameters in the model. So what do you measure? If the parameters do not change a lot, when you have a software update, it is clearly you see the update. This is the main software, and you add something like that, and you can look at the code that was added, and you can measure the impact of this code. When you have a chat GPT with more than 1,000 billion of parameters, and suddenly it's not a reinforcement. Yeah, the censorship, you just change it, and so it changes maybe 100 million of parameters. What is the impact? Even if you change them slightly, well, you don't know. This is very hard to measure. So it's a problem for the regulator too.
Good morning. Thank you so much. My name is Bastian, work with the UN. With the advent of generative AI a few years ago, there came sort of doomsday scenario predictions that there's a non-zero chance that an artificial general AI intelligence is gonna emerge soon, and then it's gonna wipe out civilization. And there was this famous open letter signed by Elon Musk as well to call for a stop of the development of further AI. So what's your take on all that? Thank you.
So this is I'm going to give you a very subjective answer, okay? Because I know that some people do not agree with me. For me, this is pure science fiction. I don't believe at all that we're any close to general AI. I don't believe at all in general AI. We are extremely far. Today we have models that are impressive in terms of text, but human intelligence has so many shapes, so many forms. I mean, we are extremely far from reaching the human intelligence. And again, here we are about illusion. It doesn't work at all the way human intelligence is working. So this is going to be a problem also. So I don't believe at all in this scenario. Now, of course, you have to listen to the people who would say the exact contrary. But for me, this is pure science fiction. And I'm not the only one to say that. There are a lot of technicians saying the same thing. It's a buzz. For me, it's a buzz just to make more money. And so there are startups saying that they are started to do general AI and so on, but it's just a buzzword. We are extremely far from it and not at all going towards the right direction, even if that was our goal.
Sorry,
We should maybe move on now.
just
Okay, just one question.
one last question.
Last
I'll try to
question.
make it very short. Well, first of all, thanks. My question is, could you say something about the potential advances? You talked about symbolic learning and so on as a possible next step, the fusion. Could you say something quickly on the idea of using robots and 3D spatial learning for this kind of training things that might lead to more complex models with a better representation of world physics, laws, etc.?
Well, yeah, robots are used already and mainly using reinforcement learning. So for instance, a robot can learn how to walk from reinforcement learning or stuff like that. So whenever it falls, but today, one limitation clearly is the fact that robots, the sensors of the robot are very, very simple compared to a human being, all the senses we have. Okay. And we would need to do a lot of progress in the design of robots to be able to do some very subtle things. Now, yes, the robots they have this kind. Some of them have these kind of models. Well, especially the robots that are talking. But I don't know if you were really mentioning that. You were more, I guess, mentioning the robots and that want to try to learn about our world and the 3D world and trying to do some stuff in the world. When I was mentioning actually robots learning by reinforcement learning, these are not generally real robots because it takes too long. Again, we are not at all close to reproduce the way the human being is learning. A child, in order to learn how to walk, it takes, I don't know, a year and a half, and it's a trial and error process. But it's a trial and error process with how many examples, how many trials? I don't know, maybe 1,000. Okay. But here for reinforcement learning, we are talking about billion of trials in order to be able to. So Google had this virtual robot that didn't know anything. So there was the law of gravity and so on in a virtual world. And the robot didn't know it was a human being, like with bones and stuff like that, but virtual. And it didn't know how to walk. And he learned to walk by reinforcement learning. So when it failed, it says it's not good, I'm trying again, and so on and so on. but it's used about, I don't know, 10 billion trials, something that, I mean, so we are very far from the comparison with a human being.
To continue with the presentation. Thank you.
Okay, so if I come back to the first question, actually, we were talking about the data and how important the data is, because if you remember, the first question was about the fact that the Gen AI is generating data that now it's taking back, so there is a loop where, and you see that it can be a source of bias. So data is at the heart of AI, and the quality of data is very important, very, very important. To be sure that the data is of good quality, is standardized, and so on. And for many business verticals, I might say, I consider, and I'm not the only one, that the AI revolution is above all the data revolution. The main problem is the data. It's not the algorithm and trying to find some new algorithm and so on. The main problems comes from where and which data to use to train the algorithm. And the main problems, and we will be discussing these, so I'm not going to spend too much time on that. We'll discussing these during the panel. I would say there are three universal problems about the data evolution. The fact that it's very hard to find big corpus of data. The data is generally scattered everywhere. When we're talking about health data, okay, you have data from one hospital, even if it's a huge hospital, it's hard to have a database with all the hospitals of a country. You have a problem of data interoperability. It's a technical term, but basically that says that when you mix two databases, like two databases from two different hospitals, did they use the same code? And it's in terms of semantics, are they considering the same disease? You know, beginning of COVID, I was mandated by the Prime Minister in France to facilitate access to data for important projects. So we know that the data from the emergency services are extremely important because it allows you to follow the dynamics of the pandemic, okay? Because that's where the first cases happen, okay? Now we had a major problem, and every countries were facing the same problem. It's the fact that in the emergency services at the beginning of COVID, well, we didn't have PCR tests. So basically, every emergency service coded COVID with different criterion. Okay, some of them said, okay, when I see this symptom, this symptom, this symptom, I say it's COVID. Some of them said, no, it's this and this symptom. So basically, each emergency service was talking about a different disease. The definition was not the same. So gathering all this data was totally useless. This is interoperability. It's extremely important and extremely difficult to achieve, extremely difficult. And then you have data governance, we'll be talking about it also, which is a major problem because accessing to data, you go through regulations, you go through valorization rules and so on, and it's not an easy process. I don't know any country where it's very easy. So these problems I think, are really universal problems on almost all verticals, and problems at the level of institutions, countries, European level, global level, and even, I mean, I've been working a lot in big private companies. They have the exact same problem, interoperability, governance. They have major governance problem about their data. I'm not talking about the GAFAM. The GAFAM are kind of an exception. But the classical big private companies, they have major problem about the data. So when we're talking about the data, what types of data are we talking about? There are different types of data. We're talking either about structured data. Structured data means basically data that falls into a table. Okay, so you have numbers or you have categories and so on. And then you have unstructured data, which is the most common type of data. So it's like free text, audio, genomic, image, video. So there is no structure in the data that is given. It's just raw data, and the AI has to structure the data and try to get the information. Okay, I just put a focus on the satellite images, which is there is a big boom today on the application of AI on satellite images, with a lot of applications on finance, ecological transitions, surveillance, alerts. I mean, many applications, and you have so many startups today about that, which is really crazy. And data from different sources, so personal data, of course, And data regulation, of course, then plays a fundamental role in the development of AI. Ownership, governance, consent, sovereignty. About ownership, just a fact that is just to tell you, of course, I am sure you are aware that Europe is totally different from the US in terms of this kind of regulation, especially today with Trump. But just to give you one example, in the US, you own your health data. You are the owner of your health data. You can sell them. In Europe, there is no ownership of health data. It's a characteristic of your person. So you cannot sell it. It doesn't mean anything. Okay, you can be paid to give access to the data, but there is no way you can sell it. These are huge, have huge repercussion on the use of this data. So regulation, data regulation is extremely important for AI. Data from different sources, so it could be also, of course, data from the private sectors, and with, of course, all the problems we know about the on-premise deployment or not, and the fact that you can have your data stolen and sovereignty and stuff like that. And you have open data, which is a very important movement today, and that you should know about if you don't know about. This is data that is freely and publicly available information. Some of the countries are extremely developed in terms of open data. You know, there is the Open Government Partnership that was built by Barack Obama. So it's a partnership of many countries that open some data that are extremely useful. I mean, in France, we have a lot of open data that are extremely useful for AI. And you have you have a site with an open data barometer. So you can see that Canada is first, United Kingdom, and so on. So this is a ranking that is updated regularly about which country is really participating to this open data movement. Okay, and some major regulatory and ethical issues. So bias in data, we discussed that already. I can give you tons of ideas, tons of examples, sorry, about AI that have been developed and that were biased because of the data that was used. And one of them is the Thai example. This is so before ChatGPT, Thai was a LLM model by Microsoft, and they deployed it on Twitter, and I think they let it alive for 16 hours, and after 16 hours, this is the kind of tweets that it was tweeting. Okay. So it was a combination of reinforcement learning because they were using reinforcement learning, but not censorship, just trying to satisfy the user. So of course, if you were provoking and saying to the chatbot that you wanted some violent content and so on, it was giving to you this kind of content. And it's a combination of that and the fact that most of the text that Thai was trained on was a very old text from Alabama, from the South states that were extremely racist at the beginning of the 20th century. So there was a major problem about the texts that was used for training Thai. So this is an obsession for any data scientist when you develop an AI algorithm. Are my data not biased? Are they representative of the use I'm going to make with the AI and so on? So this is a very, very important problem. This is another example of software that is deployed in some of the you see has been used by the US states of New York, Wisconsin, and California. So it's in Florida. So it's not just in some South states. So it's an algorithm that helps the judge, that the HUD judge can use in order to evaluate the risk of some person to be a recidivist. Okay. You can imagine the number of biases that can be in such an algorithm. Supervised, of course, it's supervised algorithm because it was trained on some data. So of course, when the algorithm sees that somebody is, we are asking a question about somebody who is black, well, of course, the score is high compared to some white people, okay? You see here, the team found that blacks are almost twice as likely as whites to be labeled a high risk, but not actually very often. Well, there are plenty of problems of bias here. Another major problem is the black box. The black box is not the fact that we would not know what is the computation the AI is doing. Actually, we know perfectly what the computation is, but the AI does not explain it. Let me give you a simple example. Imagine I'm at a hospital and some day there is this doctor coming and say, Emmanuel, you can go, you are not ill anymore. I said, how do we know that? He said, oh, that's the AI system. Okay, but what was the computation? Oh, we can give you the computation. He took your temperature, he multiplied by that. He took the square root of the size of the cell in this image and so on and so on. And it arrived at a score of 0.6. Above 0.5, you can go out. You are not sick. I said, oh, come on, but this is very risky. Oh, don't worry. There is a 1% risk that there is a mistake. Okay? Nobody would accept that. This is what we call the black box. We need an AI that says, you can go out of the hospital because your temperature is back to normal. That is what we mean by not being a black box. Okay? So that the AI system has in itself a way to explain how the decision process was made. I decided that it's a cat because I see the tail and the ears of the cat. Okay? This is hard. A lot of researchers are working on that. And it's very important, of course, for regulation, for safety, for many stuff. And please don't think that when you are asking to ChatGPT, why did you answer that? This is a solution for black box. What ChatGPT will tell you is just, again, a completion of the most probable word, one after the other. It will never tell you really what was the process, the decision process that was used to answer the answer you are questioning him about. Okay, so explainable AI is really about building algorithms that are self-explainable, which is not at all. These LLMs are not at all self-explainable. Regulation, AI in data, so regulation around the world. In China, we will be discussing that also in the panels, but I just wanted to mention that. It's heavily regulated, radically different political system, of course, than ours, but it's but very, very heavily regulation. In the US, there was the Biden's executive order that was overturned by Trump. And in Europe, so now there is hardly any regulation, I think, in the US. And in Europe, we have a lot of regulation. In China, okay, I'm not going to read everything because I want to leave 5 minutes for the questions. Just two things that are, I think, interesting. Respect for intellectual property rights. This is clearly stated in the China regulation. And another thing, which is this one, tools and contents must comply with socialist values. At least in China, they are clear. The alignment of the chatbot are done along the lines of the socialist values. So we know what the censorship layer is. OpenAI, we don't know at all. What are the values that are pushed by OpenAI? So I'm not saying this is great, China, but I think this is interesting. I mean, this is interesting. The former Biden's regulation in the States that was canceled by Trump was focusing on the responsibility of the stakeholders, as always in regulation in the US versus Europe. I'm not going to go through it because it's no longer, it's outdated today, but it's interesting to see that it's always the same thing. In Europe, we are trying to certify the AI so that you have the right to deploy it. In the US, the actor has some responsibility when it deploys it. You don't have any certification. So I will finish with the AI Act, where it's risk-oriented, unacceptable risk, high risk, low risk, minimal risk, with some kind of GDPR incentives, like enormous amount of fines if you don't satisfy the regulation. And basically, it's a level of certification, a level above, and you have a special text about these big models that are called general purpose AI models, so these foundation models of the LLMs and so on. And there are like the small ones and the big ones. So there is a number to differentiate between the two of them, but and just know that the ChatGPT and the big models, of course, are here. And so it starts in August, and nobody still knows really how it will be applied. But as is, it is likely that ChatGPT will no longer be allowed to be deployed in France because they will have to, for instance, give some information about how the censorship layer was done, what text they used, and so on and so on. So, but we will see how the European Commission will deal with that and how each member state will instantiate the law. It's not clear, but it will start in August. And these things will be heavily discussed. These factors, geopolitical factors, will be heavily discussed during the panel. So I'm not going to use, I prefer to take some questions if there are any. Thank you very much.
Thank you very much for your informative presentation. My name is Akira from the UN Secretariat. I have two quick questions for the first part of your presentation. The first question is, you explained the 4 different types of AI, but what is the next level? The reinforcement learning is no, I don't think this is the final version. So what kind of improvement AI researchers are seeking for the next generation of artificial intelligence? And the second question is, when is technological singularity estimated to be reached? You have one slide compared with the 3-year kids and the AI 2012. This is very huge difference at that time. But when will be the same level of the human being? Thank you.
So first question, I think I answered partly what I think, and a lot of people do think that the next generation will try to use the best of both worlds, the best of both approach of AI approaches. So trying to use LLMs along with knowledge database, logic rules, and so on, and try to make these LLMs being able to use that. This is a challenge. We have not reached it yet at all. But clearly, this is one thing that a lot of people are working on. Now, you have a lot of people also that start from scratch. If you hear Yann Lequin, for instance, he believes that the way we develop AI today will never, I mean, we have reached like a level and it's going to be very hard to go above that level, and we have to rethink again from scratch. So he's one of the person that thinks that we should mimic, I think, more the way the human brain is working, because we've lost totally that today. So there are different branches now, different paths that the people are following. About the singularity point, well, clearly 2012 was one, but it doesn't change totally the world. I mean, that's my belief. ChatGPT is one, clearly. I mean, what we've seen. I don't believe in criticality where, a lot of people say that's the end of all the jobs and so on. And yes, some jobs will be ended, but there will be creation of new jobs. I don't think it's the end of the experts. I know that some people say we will not need experts anymore very soon. I don't believe in that at all. We do need experts more than ever to train the algorithms and to monitor the algorithms that are deployed. The monitoring part is extremely important, and we do need experts from that. We do need doctors. We do need experts in all the fields. Now, the role of experts is changing. That's clear. So it's moving, and it's moving a lot, but we still need experts. So I don't believe in the criticality that will change totally the world that I guess you can find in Harari books or stuff like that. I'm sorry, but I'm not buying that.
Ok, donc merci beaucoup pour l'introduction très informative. Je suis Shihiro de la mission japonaise ici auprès des Nations Unies. So my question is about geographical landscape. Maybe we'll talk about it that more on the panel. However, I'd like to know your view from the purely data perspective. So I assume that the majority of data is generated in English. So would that have impact on the outcome, like a production that we get other some of the data, or since it is not, it's because the data is themselves highly interoperative, so there's not much like domination of English generated data or not? Thank you.
Yes, we will be discussing that, but I will be moderating the panel, so I will not be talking a lot, so I can give you my my view. Um, yes, it's a major issue, and we have to move fast. I mean, non-English speaking countries, we have to build our database of quality and so on in our own language, because we really have a problem of even taking the algorithms made in the US, adapting them in Europe or in Asia, in any other countries is a major problem. It's not that easy, and we have some biases and stuff like that. So yes, this is very important. And actually, even if you look at the US, I think I don't remember the exact numbers. I will name them again during the panel, but I think that most of the data that are used in the US for training algorithm, they come from 5 states in the US. It's like 90% of the data come from 5 states or something like that. So even within the US, you have a problem of representativity, enormous, and it is a major problem.
Thank you very much. I'm Joanna from the French MFA. I had a question about the American Golden Dome project, which I think is deeply rooted in satellite data and will gather plenty of investments in this field. I was wondering whether you thought it would I mean, whether you foresee a significant evolution of IA around this project.
I'm not so sure I have the expertise to give a very an answer that is clear and well-sided. You will have to ask this question to the second panel. I think there will be better experts. What is clear is that satellite is playing now a huge, I mean, is coming in the AI world, really. It's a huge application, and there are many applications now. Yeah, I saw the announcements and the enormous amount of money that are invested. It's hard to know whether it's going to lead to something that is really change significantly the way all that is working or not. I'm not that clear for me. It's not that clear, but I'm sorry. I'm not an expert on that subject. I prefer not to answer in a definite way.